Good afternoon, everybody. Welcome to video 5, Separation of Matter. When we are done with this video, we will be able to identify how we physically separate these things. Earlier, we talked about mixtures being able to be physically separated. Now, today, we're going to focus in on those techniques. How do we separate certain things? And here in this picture, look, this is a little bit of what's called a fractioning column. And if you look real quick, you can see how we get gasoline. We have fuel oil, lubricating oil, diesel oil, kerosene oil. This is different levels of separation give us different things from the same product. So, how do we separate matter? We talk about separating Skittles, we can do that. We talk about separating Gorp, we can do that. I see chocolate and seeds and whatnot here. So our first type of standard separation is filtration. So I use filtration for physical separation. There's a piece of paper in the funnel. I'm pouring the liquid down the stirrer so it pours directly in. And in the bottom I get liquid, and then the solid stays up top. The undissolved particles remain in the paper. I'm used to separate sand and water, heterogeneous. We could also centrifuge, but we're not doing that. That takes a little bit bigger of an apparatus. Watch glass evaporation. So this is a Bunsen burner underneath. And in the crucible we have liquid inside with some stuff in the liquid. If I boil off the water, the dissolved solid will stay at the bottom of the residue. The solute or the liquid escapes. This is used for homogeneous. Now remember that liquid inside there, let's say it was Kool-Aid, right? Or salt water. When I look at it, it looks homogeneous. Okay, I can't see a difference in it because it's all dissolved up good. But as I slowly take that water off, I'm going to be left with that salt residue or that sugar residue. Okay? Crucible evaporation is very much the same thing, of course. Just a different kind of a hardware. Distillation, organic chemistry. So what's happening here is something similar, except for I have two liquids now. So they're both in here boiling away. And one boils at a different temperature than another, and off it comes as gas. The gas is forced down through this cooling tube, and it's going to bring that gas back into liquid. Boom. Now I can separate two liquids. Physical separation. Separate solute from solvent because of difference in boiling temperature. It's really done for two different kind of liquids. This is the most important part here. In here, it's all liquid. Homogeneous can be removed to remove impurities from water. This would be a very expensive way to take salt water and boil off the water and leave the salt behind. But what it does allow us to do that the previous ones didn't allow us to do is to recapture that gas and turn it back into liquid. Chromatography. We did a little bit of this in living environment. It's another physical separation. Here, the barely touching green is going to go up the paper. Okay, and it's going to go up the paper based on, remember the smallest ones are going to go farthest. Right, so size and solubility. Again, a homogeneous solution. That green in the bottom looks all one color. I can't see different things in that. There's lots of different chromatography. So, on the other hand, chemical separation requires reacting a sample with something else in order to turn it into a completely different thing. Remember when we chemically change something, it turns into something else? So now we should be able to differentiate between the different separation techniques, and when we are given a problem where we have certain things like, say, sand and water, now you can describe exactly the apparatus you would be using to separate that. Okay? All right, that's it for video number 5. See you guys tomorrow in class.